Hi all, today's topic is classification of the state for of problem 1. Find the nature of the state of the Markov chain with the transition probability. Here the transition probability has been given in the question. Sometimes they will not give the transition probability, they give like a statement. So we have to write a transition probability and then find the nature of the state. So now transition probability has been given. So when you find the nature, before going with the nature, we have to find p squared. P power 1 is given in the question. P squared, P cube and P power 4 if needed means P5 also we need to calculate the data. So this can be calculated in a calculator. P squared means P into P you multiply it or normal manual also we can do it. Okay. So we have to calculate. Surely we have to calculate. Then only we can decide upon whether it's satisfied. So first the conclusion, it is nature is nothing but conclusion or classification. So what it is there means the classification of the nature, it is only two types. It may be a ergodic or it may be a not ergodic. Ergodic is nothing but irreducible. Irreducible and should be finite. Okay, irreducible and finite. All the elements should be finite means it is more than it should not be 0, more than 0. It should be any data, it should be more than 0. So finite and irreducible and aperiodic. It should be aperiodic plus non-null persistent. If aperiodic means non-null persistence also it's satisfied. So if all the three conditions are satisfied, then we say that it is a ergodic. Any one condition it is not satisfied also, it is not a ergodic. So first P1 is given, P squared I have calculated, P into P, same way P cube and P power 4 roughly I have calculated. Okay, so after the calculation, it's irreducible is nothing but the definition of irreducible is every state is communicated with every other state is the definition. So like that you know, if I tell you can't understand. What do you mean by that means Pij power n is greater than 0. So what do you mean by that means every state now what do you have to do means what is this first state a11 element. So everything with respect to p11 element, p12 element, p13 element, p21 element and p22 element, p23 element and p31 element and p32 element and p33 element all should be more than 0, not 0, more than 0 at it may be any powers of m. Okay, this powers of m can vary. For example, P11 I have taken first element P11. You check in the question P11 means this element. It is 0. I should not take this. So next P squared P11 element it's 1 by 2. So it is P11 power 2 only. It is greater than 0. That condition only I have written. Okay. Same way P12 power 1 itself is greater than 0. Okay, correct. P13 when you take it is 0. I should not take power 1. I have to go with power 2. So it is 1 by 2. Yes, it is greater than. Same way all the condition P33. All this if it is any power it is greater than 0. Any 1 also it is not coming means it is reducible. Okay, everything is come means it is irreducible with finite element. So now you check all it's coming. So all the three states are finite and irreducible. First condition satisfied. Next condition non-null persistent. How to calculate non-null persistent means we have to calculate state wise only for state 1, state 2 or state 3. Non-null persistent state wise means only the diagonal elements. When you have this like this, only the diagonal elements P11, P22, P33. Okay. So now diagonal element at whichever power it is greater than 0 we have to write. For example, P11 power square it's greater than 0 I am getting. P11 power 4 greater than 0. P11 power 6 I don't calculate at all. So roughly it may be 6 greater than 0. Same way for state 2. So 1 I will show you. So this is our question. P11 means this. So it is equal to 0. So I cannot take P11 power 1. It's not 0. Okay. So P11 power 2 you check 1 by 2. So it is greater than 0. Same way, power 3, it is not. P11 power 3, it is not 0. P11 power 4, you check, yes, it's greater than 0. That is why this both only I have written. Which is not, I need not write at all. Only which is there, I have to write it. Same way, 2 position and 3 position. So after calculating, I have to calculate GCD. GCD, how we have to calculate means, the GCD, you check in my first video of this unit. I've given all the definition plus formula. GCD is nothing but particular M where Pij power M greater than 0. When I am getting greater than 0, the corresponding power is called as a GCD. Okay, so which power I get as 0? So it is nothing but power 2, power 4, power 6. So GCD of 2, 4, 6, I have to calculate it. Okay. GCD is nothing but 2 I am getting. So 2 I am getting. Same way for state 2, GCD is nothing but same power 2, power 4, power 6, etc. So GCD is nothing but same 2. Same way for state 3, when I do it, GCD is nothing but 2, 4, 6. So GCD is 2. All the states 1, 2, 3 has a period 2. Now aperiodic and periodic, what you have to do means, if it is a aperiodic, okay. So if it is aperiodic and periodic means, when the period D equal to 1 if I get, it is a aperiodic. When GCD only is nothing but D. GCD is called as a D. When GCD not equal to 1. Okay, it may be anything, 2, 3, 4, anything. Okay, so it is called as a periodic. So according to this, now what I am getting? 2 only I am getting. D I am getting to be 2. So it is the meaning. So it is a periodic. Periodic means it is not a aperiodic. Not a periodic means it is not satisfied. Correct? One of the condition is not satisfied. One of the not satisfied means what we have to do. It is a whether we have to write it. Yes, it is a non-null persistent only. The reason non-null persistent, because I am getting a GCD. If I get the GCD itself, it is a non-null persistent only. But I am not getting a periodic. I am not getting a aperiodic. So therefore, all the states are not ergodic. If I get answer GCD to be 1, then it is aperiodic. Then non-null persistent satisfied and aperiodic also satisfied. So it is ergodic. Only the change will be that case only. Thank you.